All right, let's dive right in. We are about to explore a substance so incredibly strange, it seems to just break the laws of physics as we know them. We're talking about quantum mechanics, the super weird rules that govern tiny, subatomic particles, but happening on a scale you can actually see with your own eyes.
So, I want you to start by asking yourself this one question. What if a liquid could do things that just seem impossible? Things that feel like they belong in a magic show, not a science lab.
I mean, can you even imagine a fluid that has absolutely zero friction? So if you stirred it, it would just swirl forever. Or what about a liquid that just defies gravity and crawls right up the walls of its container all by itself? Or a liquid that, when you try to boil it, suddenly goes perfectly still instead? And what if it could slip through cracks so tiny that literally nothing else could get through? Well, here's the kicker. This is not science fiction. This liquid is very, very real. It's called superfluid helium, and it is honestly one of the most remarkable and bizarre substances in the entire universe. So let's start by actually taking a look at this unbelievable behavior. You have to see it to believe it. Okay, so as you cool down liquid helium, it acts pretty much like you'd expect. But then, at just about 2 degrees above absolute zero, a very specific temperature called the lambda point, something absolutely incredible happens. The chaotic, bubbling liquid instantly becomes perfectly calm. It becomes such an insanely good conductor of heat that it just whisks it away instantly, so bubbles can't even form. It's unnervingly still. And then there's this. Because it has zero friction, the superfluid creates this impossibly thin, totally invisible film, we're talking like 30 nanometers thick, that just climbs up and over any surface it touches. This is called the rolling film. It will literally crawl out of an open beaker, defying gravity, drip by drip until the entire beaker is empty. It's like a frictionless siphon that works all by itself. So, how is any of this even possible? How can a liquid have zero viscosity in one experiment, but seem to have it in another? It was this huge paradox that completely stumped scientists until they came up with a really beautiful and elegant solution. They came up with this idea called the two-fluid model. They proposed that what we're seeing isn't one liquid, but actually two liquids that are coexisting and flowing through each other in the same space. The best analogy is to think of it like a ghost moving effortlessly through a crowd of people. There's a normal fluid component, the crowd, with all the usual messy stuff like friction. And then there's the superfluid component, the ghost, which has zero friction and zero entropy, meaning it's in a state of absolute perfect order. And this table here really shows you that split personality. The normal part acts just like a regular liquid, carrying all the heat and the chaos. But that superfluid part, that's where all the magic is happening. Zero friction, perfect order. It's a liquid existing in a state of pure quantum perfection. Okay, but how do you prove that there are two fluids in one container? With a really clever experiment. So imagine you have a stack of disks spinning back and forth in normal helium. The whole liquid gets dragged along with it, right? Now, you cool it down past that lambda point. All of a sudden, the disks start spinning faster. Why? Because the frictionless, ghost-like superfluid component is just staying completely still. Only the normal fluid is getting dragged along. This was a direct measurement of the two separate parts, and it was the smoking gun that proved the two-fluid theory was right. The two-fluid model is a great description of what is happening, but it doesn't really explain why it's happening. And for that, we have to go even deeper, right into the bizarre world of quantum mechanics. So the secret is actually with the helium atoms themselves. They're part of a family of particles called bosons, and bosons have this really special ability. They can all pile into the exact same energy state at the same time. When you get them cold enough, that is exactly what they do. Billions upon billions of helium atoms just stop acting like individuals, and they merge into a single, massive quantum wave. They become one entity, a Bose-Einstein condensate. And this quote right here gets at just how wild that really is. It means that the entire liquid, everything in the beaker, can be described by one single piece of quantum math. The weird rules that normally only apply to a single tiny particle are now describing something you can hold in your hand. The whole liquid is one giant quantum object, all behaving in perfect unison. And this quantum unity leads to some truly bizarre consequences. For example, you can't just spin a bucket of superfluid like you would water. Since it's one single quantum thing, it can't rotate smoothly. So instead, to handle the spin, it forms these tiny, perfect little whirlpools. They're called quantized vortices, and each one carries the absolute smallest amount of rotation that quantum mechanics will allow. Okay, so this is way more than just a fascinating lab curiosity. This strange liquid is actually critically important to our modern world. And that brings us to a very real and very serious challenge that we're facing right now. So why does this matter to you? Well, take a look at where all our helium goes. Nearly 40% of it is used for MRI machines in hospitals. It's the only thing cold enough to cool those powerful magnets. And another 24%? That's essential for making the semiconductor chips inside the very device you're watching this on right now. We're talking about a multi-billion-dollar industry that depends completely on a resource that we can't make more of. Helium is a byproduct of drilling for natural gas, and right now, experts say we're in helium shortage 4.0, which means we're facing a serious global crisis of supply and demand. Now, before we look to the future, let's clear up a common and really cool myth you might have heard about superfluid helium. So the myth is that it can leak through solid glass because its atoms are quantum tunneling right through the walls of the container. The reality is just as amazing, but a little different. The leak is almost always one of two things. Either that invisible roll-in film we talked about is simply climbing up and over the top, or the container isn't perfectly solid. It's a porous material like a ceramic with microscopic channels that the zero-viscosity superfluid can just effortlessly flow right through. So no quantum tunneling through solid glass, but its ability to exploit literally any tiny path is still incredible. So where do we go from here with this stuff? Well, believe it or not, scientists are now using the unique properties of this incredible liquid to try and tackle some of the biggest and most profound questions in all of science. One of the biggest mysteries out there is dark matter. Well, it turns out superfluid helium is a perfect trap for it. It's so pure that it creates a perfectly silent background so you can listen for a very faint signal. If a dark matter particle were to bump into a helium atom, it would create a tiny detectable ripple of energy. This could be our best shot at finally figuring out what most of the universe is actually made of. And this might be the most mind-bending application of them all. Scientists are using superfluid films as tabletop universes. By creating these quantized vortices and manipulating the flow, they can create analogies for incredibly complex cosmic events, like how particles might have spontaneously appeared out of the vacuum of empty space right after the Big Bang. They are literally studying the birth of the cosmos in a lab, right here on Earth. Which really just leaves us with a final thought. From defying gravity in a simple beaker to mimicking the birth of the entire universe, superfluid helium forces us to completely rethink what's possible. It's a bridge between the tiny quantum world and our own, and it's a reminder that there are these deep, strange, and beautiful truths still out there, just waiting to be discovered. So you have to wonder, could this simple liquid found right here on Earth really unlock the secrets of the cosmos?